The Code Hard Truth, fighting bad programming one error at a time.
Hey, welcome in. So today we're talking about the Liskov Substitution Principle. And what that is in object-oriented programming, it's a design pattern. And if you understand it and use it properly, it will make your programs, your code, a lot more readable, understandable, efficient, and separate you from an amateur. Now, before we get into the actual definition and show an example, I think the best way to learn this is to look at it from 10,000 feet above. Essentially ask yourself, what is the purpose of this principle? And the best way to think about it is this. The Liskov Substitution Principle solely exists so that you as a programmer know what the best practices for inheritance are. That's it. There's nothing else. If you understand this principle and you use inheritance in your programs, then you will be using them properly. So with that understanding, let's look at the actual textbook definition of this principle. And it's this. If S is a subtype of T, then objects of type T may be replaced with objects of type S without altering any of the desirable properties of T. What the hell does that mean? Now, of course, that sounds a little bit confusing. I will show you an example. Once you see the example, it's very common sense. It's straightforward. There's nothing mysterious or abnormally difficult about it. Unfortunately, still a lot of people, when they make their programs, just don't think about this concept. But if you understand it and make it top of mind as you're writing your programs, as you're using inheritance, once again, you'll see your programs get a lot more efficient. The code will be a lot more readable, not just to you, but even more importantly to people that are looking at your programs for the first time. So let's get into it. So here's our example. I will be using WWE wrestlers again. That seemed to be kind of popular in the other video. It's pretty straightforward, so why not? So let's start off with this parent class called wrestler. Now this is extremely simplified in order to get across the point, so just keep that in mind. All we have here are two variables. One is going to be an integer stating the exact hour that the wrestler will be performing. The second one is a double that will tell us how much they make. So we have a constructor here. Once the object is instantiated, you'll be able to put in the time you want them to perform, and then once again their salary. There are some methods here that will simply just return these private variables. And finally, there is going to be this abstract method which is called isFighting. All that's going to do to the subclass that inherits it is allow for a print statement to be made regarding who that wrestler will be fighting that night. If you're a little bit confused about what this method exactly is and what an abstract class is, you could click on this link right here, and there's a quick video explaining the whole thing. So, once this class is created, we're going to go ahead and create 3 more classes. One of them is going to be the Undertaker, one of them is going to be Mankind, and the last one is going to be Paul Bearer. Okay, so let's go to this Undertaker class. So, we'll have the Undertaker extend this Wrestler superclass, which will force us to have to instantiate this constructor to the superclass, and our abstract method, which is isFighting. So in this case, all this method's going to do is print out who's Undertaker fighting that night. We'll say, for example, Mankind. So now the Undertaker has this isFighting methods all set, and he will have access to these methods as well in order to get the time he's fighting and his salary. So let's go ahead and then create another class. Let's create a class called Mankind, and here it is. Same idea. Mankind extends wrestler, constructor to the superclass. The abstract method is fighting. Mankind will be fighting Undertaker this night. All set. Finally, let's create one more class called Paul Bearer. Paul Bearer also is going to extend the wrestler class, and he's going to have access to these variables in the superclass. What time is he scheduled to perform? What's his salary going to be? And is he fighting or not? Here's where the problem comes in with Paul Bearer. For people who don't really watch wrestling or know what the hell I'm talking about, Paul Bearer isn't a wrestler. He's a manager. He's managed The Undertaker forever. So here's where the entire issue comes in. Paul Bearer does indeed need these two private variables from the superclass because he is scheduled to perform. He might be coming out the same time as the person he's managing, in this case, The Undertaker. He also makes money. So he is going to need this extension of the wrestler class. The one problem is this abstract method is fighting. If Paul Bearer extends the wrestler superclass, he's going to have to implement this is fighting method. But again, managers don't fight. So at the very core, this is breaking the Liskov Substitution Principle. Now let's look at that just one more time. If S is a subtype of T, so if Paul Bearer is a subtype of this wrestler class, then objects of type T, wrestlers, may be replaced with objects of type S, Paul Bearer, without altering any of the desirable properties of T. That right there is breaking the principle because an object of type S, which is Paul Bearer, if he replaces an object of type T, which is a wrestler, he will be altering the desirable properties of T because T is saying, hey, whoever extends me needs to be fighting that night. That's where the conflict comes into place. So when you're designing your programs, you need to think about these little aspects that ultimately will make your program more efficient and make more sense. If we take a look at our UML diagram, kind of to hammer this point home even further, here's our wrestler superclass. All of these methods are necessary for wrestlers, but only part of them are necessary for when it comes to managers. So if managers inherit from the wrestler class, it's going to be breaking the Liskov substitution principle. The way to solve this and make this more efficient is to take this is fighting method and just make it a separate interface. So when Undertaker and Mankind and Paul Bearer now will be able to inherit the wrestler class, that will make sense. But now Undertaker and Mankind are going to be implementing an interface called is fighting. That will allow for the Liskov substitution principle to not be broken. Your program will make more sense. And in the future, you'll avoid a lot of headaches and complications because this is, again, a very simple example. But imagine if you had multiple objects inheriting from a superclass with methods that they didn't necessarily need. Now you have an entire application with these objects that exist that have methods that are arbitrary. I guarantee you down the line, you're going to run into issues and have a headache and want to just blow your computer up. Not to mention, if somebody else has to go and check out your program, then it's going to be a real issue. So to avoid all that, once again, all the Liskov substitution principle is teaching you the best practices for inheritance. Make sure that the subclasses are actual subtypes of the parent class. It's all worth it in the end because it just makes your code better. Thank you for watching. Hopefully you have a better understanding of what the Liskov substitution principle is, and I will talk to you soon.